So, welcome to this class on Neuroscience of Human Movement. So, the topic of today's class will be pre-programmed reactions. So, what are these? We will have to see what these are and discuss that. So, this is part 1 and there will be one more part, I suppose. So, in today's class we will be talking about pre-programmed reactions. This pre-programmed reaction, a stretch reflex. What are the afferent sources or the possible afferent sources of pre-programmed reactions, and how does pre-programmed reaction affect when a movement is happening. So, in other words, a movement is happening, a perturbation is applied, and how does the pre-programmed reaction react, what is the direction in which it happens. Okay. We will discuss this and in some relative detail. So, to begin with, so we can consider movements as a continuum between two extremes. On the one extreme you have monosynaptic reflexes or just plain reflexes. These are these are stereotypical or difficult to modify and happen at a relatively low latencies, less than or equal to 30 milliseconds latencies, and are usually not responsive to the context. So, they are not contextual. Usually the response just exists. It need not be a perfect resolution of the problem that is caused, the perturbation that is caused. At the other end of the continuum you have voluntary movements. These are well tailored responses to perturbations. There is something that is happening, I know what is happening, I have thought hopefully within my rational mind as to the future course of action, and I am reacting. Well considered decisions that manifest as movements are voluntary actions. Now, they are not stereotypical, they are very context specific, extremely context specific. In other words, it will scale very nicely with the perturbation amplitude, the response will scale very nicely with perturbation amplitude. In other words, depending on the perturbation the response will come. So, if the perturbation is of great amplitude, the response will vary as in greatly when compared with a smaller perturbation and so on. Usually the delays are greater than 100 milliseconds, actually around 200 milliseconds, between 150 to 200 milliseconds, very context specific and they are not stereotypical. And then in the middle you have several things, here you have oligosynaptic, here you have polysynaptic, and then here after this continuum becomes hazy. It is not clear what is in the middle. There are several things in the middle. These are non-reflexes, non-reflex, non-voluntary. It is not clear what that is. Non-reflex, non-voluntary, because unless we define what is reflex and what is voluntary, it is not clear for us to say classify these properly. But there is a hazy space in this continuum. Somewhere here after polysynaptic you have a special class of reactions called pre-programmed reactions. Okay, that is what is. So, what is characteristic of these is that they have latencies between that of reflexes and voluntary movements. So, around 80 milliseconds or between 70 to 100 milliseconds. So, an expectation would then be that if that is the case, they are not going to be as stereotypical as the reflexes, and they are also not going to be as tailored as the voluntary, then it is going to be somewhere in the middle. Also the contextual nature is going to vary and so on and so forth, right. So, we will discuss that in the future slides. So, there are so many names for pre-programmed reactions, they are also called as transcortical reflexes. Although the transcortical nature of these reactions have been challenged, at least now there are hypotheses that say that this pre-programmed reactions involve a cortical loop, which is why they are called as transcortical reflexes. It is not clear what is meant by that. Transcortical means, by definition we would say that these are not reflexes, they must be voluntary is what you would think. Cortical means thinking, ideation, thinking, something is going on, right. Yet we call this as transcortical reflexes. They have relatively long latencies. So, they are called as long latency reflexes or long loop reflexes, and they are of course called as pre-programmed reactions, as we are calling. We will call them as pre-programmed reactions for the rest of the class and during the rest of the course in future slides. Another name is they are called as functional stretch reflex. It is an interesting name because it turns out that the response is dependent not just on context, but also on instruction. So, there is a functional relevance for this reflex. Because of that reason, it is also called as functional stretch reflex. They are called as M2 M3 reactions, or in some books and some papers and some people you call this as M2-3 reactions, or triggered reactions, or people like me call this as canned reactions. So, that is like if I am expecting something to happen, I have a canned response. So, for example, somebody is coming to ask me for something, let us say I have a canned response as to what I should tell them. I give them the same response all the time, every time they come I give them the same response. They coming in and asking then only acts as a trigger for my response, but the response itself is not going to vary. So, that is called as a canned response or canned reactions. There are several such names. Okay. We will call this as pre-programmed reactions for the purpose of this class and course. Okay. Suppose there is a perturbation that happens at that time, let us call this as time 0, let us call this as time 0. At around 30-40 milliseconds there is a first response that happens, at around 30-40 milliseconds there is a first response that happens, and that what is that? That is M1, that is the analog of the H reflex, or more precisely the phasic stretch reflex or the T reflex, is it not? That is the monosynaptic response, that is the phasic stretch reflex, okay. That is the T reflex, or the mechanical analog of the H reflex, is it not? Whereas, after about 70-80 milliseconds, for example, two reactions happen, one followed by the other, that are corrective in nature. So, these are called as pre-programmed reactions. This is actual data, this is a cartoon, this is real data. This is real data or representation of a real data from an experiment involving biceps flexion, I suppose. So, again note here we have called this as M2 M3, here we have called this as M2-3. That is because in some cases it turns out there are two distinct peaks, like it is here, there are two peaks here and there are two peaks here. If there are two peaks, these are M2 and M3. Sometimes what happens is that the reaction is like that, the two peaks are not so distinguishable. In that case, these two are the two peaks, but they are M2-3, they are sometimes not distinguishable and they are still called as pre-programmed reactions. That does not really affect that. So, that is, and so this happens at 80 milliseconds, 70 to 100 milliseconds, and then note voluntary reaction will follow. Here is voluntary reaction. What is a time scale? 150 milliseconds, is it not, or definitely greater than 100 milliseconds, that is about 150 milliseconds. Okay. Now, and note one does not affect the other. A perturbation will be immediately first responded to. There is a first response from T reflex and then followed by M23 and then followed by voluntary reaction. You want the perturbation to be addressed properly, but yet you want to address some of these things immediately, some of these are very urgent, right. So, that those responses, so one followed by the other happen, first M1 then M23 then voluntary, first M1 then these then voluntary, in that order all of them happen. Usually none of these are skipped, usually all these happen. In some cases voluntary reaction may not be required, because the reflex itself may be able to overcome the perturbation, depending on the amplitude of the perturbation, that might be sufficient. But in any case there will be some, if there is a requirement, then voluntary reaction will happen. In rarely voluntary reactions may not be required. Okay. So, this is pre-programmed reaction that happens at around 80 milliseconds. What are the features of this? So, what are the features of this? So, let us remember, is this a stretch reflex? That is the question that one would ask, because we defined early on stretch reflex. What is stretch reflex? If the length of the muscle changes, then change in the level of the length is responded to by a tonic stretch reflex, is it not? That is what we said. The first response we called as the phasic stretch reflex, and that is the transient and the tonic stretch reflex is a steady state. We said this in the previous class. Now, is it that the pre-programmed reaction is some form of a different name of a tonic stretch reflex, is the question. The answer is actually no. In the previous slides, if you see in the previous class, when we discussed tonic stretch reflex, the length is changing like that, for example, then the the tonic stretch reflex amplitude varies by that much, for example, right. Then the length changes by a higher amount, then the reflex amplitude also increases, right. However, pre-programmed reaction, that does not happen. In pre-programmed reactions, what happens is the stimulus or perturbation amplitude has very little or no correlation with the response, or in other words, it is the presence or the absence of the stimulus that is detected. Is there a stimulus? Yes, then there is a response, and that response is going to be canned. So, the perturbation actually acts as a switch, as like an on off switch, a trigger, that is why it is called as a trigger reaction. So, if the perturbation is there, then there is going to be a response, the presence or absence of the perturbation alone, right. So, not just that, the response happens in the case of a stretched muscle, in the case of a shortened muscle, in the case of a muscle whose length does not change, all kinds of things happen. So, because of this reason, this is not a stretch reflex. Pre-programmed reactions are not stretch reflexes, and especially because the amplitude of the response is independent or very poorly correlated with the amplitude of the perturbation. Okay. In other words, this is the pre-programmed response represents a sort of non-graded response to the presence or absence of the stimulus, like action potential. There is a perturbation, that perturbation is detected, there is a response. By the way, that does not mean that the response is going to be stereotypical all the time, there is still going to be context specific response. In other words, there can be multiple pre-programmings that can be done. Depending on the stimulus, which one of these programs will have to be executed will have to be decided. I am speaking as if this is a computer that is executing, and saying there are multiple options or multiple actions that can be prepared, and which one of these is going to be executed depends on which trigger is pulled. Whichever trigger is pulled, the response is going to happen, but pulling the trigger harder is not going to change the response. So, in that sense it is different from action potential. Action potential is always the same, here there is going to be context specificity. Okay. So, in other words, the perturbation only acts as a trigger, very critical, very important distinguishing feature of pre-programmed reactions. Okay. Now, a question is, I have said that these responses are prepared in advance. Who prepares this? That is the question. Who does that work? So, here in this slide we have said central command, not clear what that means. Central could involve spinal cord, brainstem, motor cortex. For the sake, since I actually do not know what the answer is, I am going to say that this is some higher center. We like to think what that means is, probably M1, probably the excuse the terminology, what I meant was probably the primary motor cortex or M1 is a response, probably, we do not know, that is preparing the reaction, but that does not mean that, remember, if somebody is involved in the preparation of the reaction, that does not mean that during execution that has to be involved. Preparation can be made by this part, this loop, then reaction can happen later. Okay. Now, and what are these afferents? Now, that is another question, because in the tonic stretch reflex, in the previous cases, in the monosynaptic reflex, in the oligosynaptic polysynaptic reflexes, we saw what the afferents are. These are muscle spindles, these are Golgi tendon organs, right. If the muscle is stretched, muscle spindles are going to fire. If the muscle is contracting, Golgi tendon organs are going to fire, causing respectively a response through 1A and 1B, or 1A interneuron, 1B interneuron, and so on and so forth. We have seen that. What are the afferents in this case? I have just said afferents. Afferents can be n number of things, because they can be muscle spindles, they can be 2 muscle spindles 2, as in 1A afferents, 2 afferents, 1B, which is Golgi tendon organs, they can be cutaneous receptors, they can be thermoreceptors, they can be by the way, when I say afferents, sensory information, right, it can be an auditory afferent, I can hear it can be an afferent that is visual, there can be a flash of light, it can be anything. So, the afferent source of the pre-programmed reaction can be auditory, visual, or any other modality. Note, it can also be vestibular. What does that mean? That means there is a change in the posture, right. I can be just pushed a little, my posture can vary. So, my posture of the head with respect to the ground or with the rest of the body, if it varies, then there is going to be an immediate corrective mechanism, right. So, it can be vestibular, it can be any other modality. It can also involve the 1A afferents to cutaneous receptors, etc. That does not mean that we are excluding them from the source of afferents, but in this case the response can also be triggered by auditory and visual and vestibular and other senses that are not discussed previously. Previously we only discussed the case of 1A, 1B and 2 and so on. Okay. So, can be provided by proprioceptors, which is muscle spindles and Golgi tendon organs, right, a flash of light or by a loud tone, but remember that signal must carry sufficient information to distinguish as to what the trigger is, right. So, it need not tell me is, of course, it is not, the response is not going to change with the amplitude of the stimulus, but there must be enough information for me to distinguish it from other stimuli. Is it asking me to go in that direction or that direction? I need to be able to distinguish that, otherwise there will be no reaction, there will be only be confusion. So, as long as there is sufficient information, this acts as a switch, and then that switch or trigger is recognized, and then a response is facilitated. An example, the classic example is the case of the grasp reflex, right. Suppose there is the cup and you are asking an individual, you are asking a person to hold this cup, I mean keep your hands in such a way as if you are going to hold the cup, but do not hold the cup, just keep the very close, yeah, closer than that, yeah, very close, like that, right. Now, at less than 1 centimeter, right, at less than 5 millimeter, I am keeping the fingers. Now, suddenly pull the hand through a motorized system or something. When you do that, right, for example, what usually happens that people grasp this object. Actually, it is not a better example is, a better way of doing this is, ask the people to do this, right, just make a loud noise, boom, like that, people will grasp this. You did not ask them to grasp that, you just said keep the hand as if you are going to grasp. There is a difference between keeping your hand as if you are going to grasp and actually grasping. when you are keeping the of course, there must be an element of surprise, right, that is the perturbation. If I know that this is going to happen, if I know that you are going to say boom, then I will decide not to react, or so that means I can change this depending on instruction or intention. I know that you are going to say boom, in that case I will not react. If I decide not to react, it depends on intention and instruction. So, that means it must somehow involve cortical loop, but not clear, still matter of debate. So, if I keep the hand very close and disturb in some sense, like for example, say make a loud tone or a loud noise, people will immediately grasp. What that means is that we are pre-programming the hand and fingers to grasp the object if needed, and then we are bringing in a perturbation. That perturbation acts as a trigger to grasp, and then they grasp it, even though there is no instruction. By the way, this should not be predictable by the subject. I should be able to distinguish the stimuli, but I should not know what the future perturbation is. If I know what the future perturbation is, then there will be no surprise. So that is the other feature. Okay. Now, what happens if the perturbation occurs during a during a movement? If let us remember, during a fast voluntary movement, what is the pattern of EMG? We said what is the pattern of EMG. We call this as the Tri-Phasic EMG. In one of the previous classes we have discussed this. That is the case in which the agonist fires first, and in the middle of the movement the antagonist fires, and then later the agonist once again fires to produce a movement like that, right, a displacement profile like that, is it not? This is something that we have seen. We call this as the Tri-Phasic EMG pattern. Okay. Now, if a person is performing a movement and a perturbation is applied, right, like that. So, that is the perturbation. The arrow mark says where the perturbation happened, then the responses are seen at a latency typical of pre-programmed reactions. So, that distance, that time is 80 milliseconds. Now, importantly, it is not, but it is not stereotypical in the sense, depending on what is the direction of the perturbation, the response will vary. So, the activity of the muscle that acts against the perturbation increases, which is what is shown in the bold lines here. That is the response of the muscle that is acting against the perturbation. So, if this muscle is acting against the perturbation, its activity will increase, while the activity of the muscle that is assisted by the perturbation, which is this muscle, decreases. Earlier it was this, now it has decreased, reduced. Earlier the muscle that was acting against had that amplitude. Now, the perturbation has happened, its activity has increased. So, the response is not stereotypical, it is context specific. So, generally this is what happens. Okay. So, what are the features of the pre-programmed reaction? So, some of the features to remember are, it is strongly controlled by instruction or intention. It is strongly influenced by what the instruction is. If you tell the people to not react, for example, the response will be very different. And a person can pre-program any function. So, anything can be pre-programmed, and amplitude does not correlate well with the response amplitude does not correlate well with the stimulus amplitude. Okay. Now, what else? We will see what else is there in the next class. So, we have seen what are pre-programmed reactions in this class, and we have said that it is not a stretch reflex. We have said that the afferent source of pre-programmed reaction can be anything, can be the vision, can be auditory, can be vestibular, can be any other afferent source, and during movement perturbation the muscle that is acting against the perturbation, its activity increases, the muscle that is acting along with the perturbation, its activity decreases. Okay. So, with this we come to the end of this class, we will continue in the next class.